Imagine moving entire rivers not just around cities, but across thousands of kilometers, through mountains, beneath cities, and even across earthquake-prone regions. That's exactly what China is doing. The country is constructing the largest water transfer system ever attempted, a colossal engineering effort to redirect water from its lush, flood-prone south to the parched, overpopulated north. This mega project, called the South to North Water Diversion Project, is not just a series of canals and tunnels. It's a game-changing attempt to reshape the geography and future of China's water supply, aiming to move 44.8 billion cubic meters of water annually, enough to fill 18 million Olympic swimming pools. But while the engineering might be revolutionary, the implications, environmental, political, and social, are equally enormous. Mao's bold vision. The seeds of this monumental idea were planted as far back as 1952. Chairman Mao Zedong, while examining a map of China, made an audacious suggestion. There's more water in the south and less in the north. Why not move some of it? It was a deceptively simple idea that masked the complexity of making it real. Fast forward to the early 2000s, and China began turning this vision into action, launching one of the most expensive and labor-intensive infrastructure projects the world has ever seen. Why the North needs water so badly? China's water distribution is imbalanced. While the southern regions enjoy abundant rainfall and fast-flowing rivers like the Yangtze, the northern half suffers from chronic water shortages. Yet the north is where more than half the population lives, where Beijing, Tianjin, and many major industrial hubs are located. To support its rapid urban and industrial expansion, the north has been over-relying on underground aquifers. In Beijing alone, groundwater levels dropped by 5 meters annually, with some wells needing to go more than a kilometer deep just to reach usable water. Meanwhile, the south faced the opposite problem: frequent floods, overflowing rivers, and excess rainwater. The contrast was dramatic and unsustainable. 3 routes to transform a nation. The Eastern Route. The Eastern Route follows the path of the ancient Grand Canal, a waterway with a history spanning over 2,500 years. But instead of merely reviving the old infrastructure, engineers had to modernize it completely with new canals, underground tunnels, and 23 powerful pumping stations, each capable of powering a small city. Water is sourced from the Yangtze River near Yangzhou, then pushed northward. In one engineering marvel, water is even funneled underneath the Yellow River through colossal underground pipes, a river literally flowing beneath another river. The Eastern Route began delivering water to Shandong Province in 2014, and shortly after reached Tianjin. Today, over 10 million people benefit from it. But it hasn't been all smooth sailing. One major issue was pollution. Much of the canal passed through heavily contaminated regions, where factories and farms had been dumping waste for years. Engineers could not just switch on the pumps, they had to first clean the water, involving massive investments in treatment facilities. Some local communities, like fish farmers near Dongping Lake, complained that the new water killed their fish, blaming pollution from the Yangtze. While follow-up studies confirmed an overall improvement in water quality, rebuilding public trust proved harder than cleaning the water itself. The Central Route. If the Eastern Route is the most industrial, the Central Route is the most elegant in its design. Known as the Grand Aqueduct, it begins at the Dongjiangkou Reservoir on the Han River and stretches more than 1,200 kilometers, all without a single pump. How? Engineers raised the height of the dam, allowing gravity to do the work. Water flows naturally downhill, traveling through an intricate network of channels, bridges, and tunnels, eventually reaching Beijing. This route now supplies about 1/3 of Beijing's water, helping over 20 million residents and significantly replenishing groundwater reserves, rivers, and lakes around the capital. However, building the Central Route came with serious social costs. To make room for the enlarged reservoir, over 330,000 people were relocated from their homes in Hubei and Henan provinces. Many were promised better housing and compensation, but the upheaval remains a deep scar for many displaced families. and taking water from the Han River had downstream consequences. To counterbalance the reduced flow, China is constructing another mammoth tunnel from the Three Gorges Reservoir to refill the Han. This tunnel, expected to be completed in a decade, will be the deepest and longest water tunnel on Earth, reaching 1 kilometer underground. The Western Route. The Western Route is by far the most ambitious, dangerous, and controversial leg of the plan. The idea is to divert water from remote mountain rivers on the Tibetan Plateau, including parts of the Mekong and Brahmaputra, into the Yellow River. But there are several huge problems. First, these rivers are international. They also flow through countries like India, Vietnam, Cambodia, and Bangladesh. Any diversion risks diplomatic fallout and could devastate downstream ecosystems and communities. Second, the region is one of the most earthquake-prone in the world. Building massive tunnels and dams here invites the risk of landslides, tunnel collapses, and catastrophic failures if a big quake strikes. For now, the Western Route remains on hold, but not canceled. China has signaled it may proceed in the future if conditions allow. The costs. Is it worth it? By 2024, China's South to North Water Diversion Project had surpassed 500 billion yuan, over $70 billion, in costs, covering only the eastern and central routes, with ongoing expenses for maintenance, environmental management, and future upgrades. Critics argue these funds could have been better invested in alternative solutions like desalination, wastewater recycling, or repairing leaky municipal systems. They also warn the system is increasingly vulnerable to climate change, as southern China dries and the glaciers feeding its rivers shrink. Supporters, however, claim only a mega-project of this scale could effectively address the North's chronic water shortages. They highlight improved water quality in Beijing, the revival of rivers and aquifers, expanded irrigation for farmers, and reliable supply for industries. Still, disparities persist. Some rural villages see water pass by in canals they can't access, and the open-air design leads to significant water loss through evaporation before it ever reaches its intended users. Can technology improve it? To improve efficiency, China is turning to technology and smart water management for its South to North Water Diversion Project. The Central Route, with its 60 check gates, 90 diversion points, and lack of regulation reservoirs, presents significant control challenges. To address this, digital sensors and real-time tracking systems are being deployed to monitor water levels, flow speed, and quality metrics. These innovations enable much faster and more precise adjustments. Water delivery in some areas can now be altered up to 5 times more quickly than before. As climate variability increases, these technological upgrades are becoming crucial to ensuring water reaches the right places at the right times. A gamble against nature? Despite its scale and cost, China's water project is ultimately a gamble against nature. Rising temperatures, shrinking glaciers, and changing rainfall patterns threaten to reduce water availability in the very regions this project relies on. If the Yangtze River's flow declines significantly, there may not be enough water to send north. This would turn the world's largest water diversion system into an expensive, underused pipeline. The truth is, while China may have mastered the engineering, nature still holds the final say. Should China build the Western Route? So here we are, staring at the future of one of the boldest infrastructure projects ever attempted. Should China go ahead with the Western Route? On one hand, it could provide essential water for millions more and complete the dream Mao envisioned decades ago. On the other, it risks international tension, environmental disasters, and could further destabilize already fragile ecosystems. Maybe the better choice isn't to build bigger, but to build smarter, to combine smaller, sustainable solutions with cutting-edge management of existing resources. Either way, the South to North Water Diversion Project will go down as one of the most ambitious feats of human engineering in history. Whether it will be remembered as a success or a cautionary tale remains to be seen. And that's the story behind one of the boldest infrastructure projects ever attempted, the South to North Water Diversion Project. If you enjoyed this deep dive into one of the wildest engineering feats on Earth, make sure to smash that like and subscribe. Thanks for watching, and see you in the next one.